This is a reminder, Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate, but please don't share personal information during the class for your own security reasons. Yeah, very similar to that, isn't it, Mr. Alch? All right, everyone. So go ahead on the whiteboard. Today, I want to know, what is a success that you have had in the last week? So remember, obviously, I was out all of last week, so I want to hear about the successes you've had. Remember, we've been talking all about our habit building, goal building, or just in general, tell me what is a success that you've had in the last week. Oh my gosh, that's so exciting. Awesome. I see Efren on the board. Go ahead, get your answers up there. Something that was a success for you last week could be something small, right? Were you able to keep up some of your habits, some of your goals that we've been working on? Could be something big like Efren put on the board. Go ahead, type up there. I want to see answers from Amanda and Andrea and Bradley. Let's hear from Dolly. I see Arrow on the board. I want to hear from Donnie and Tony. Let's get our answers up there. Ethan, Israel, let's go ahead. I want to hear from you too. And Jacob, J, Jasmine, Letty. Go ahead, tell me a success that you've had in the past week. Looking good. Want to hear from Yoleze and TJ, Shoshana. Again, open up your links if you haven't already. Password is in the chat box. I know we have some people joining us. Good to see all of you. Awesome. I see Amanda on the board. Let's get some answers from Rozzy and Parker, Orlando, Michelle. There we go. Looking good. Let's get 3 more answers at least, and then we're going to go ahead and keep on moving. But again, we always need lots of participation to make sure that we're learning, as well as it helps class go by even faster, which is always a good thing when we have some limited time. All right, so still waiting on a few more answers. Go ahead, tell me on the whiteboard, what is a success that you've had in the last week? Again, it can be something little, it can be something big. It doesn't have to be something big though. Go ahead, tell me on the whiteboard or in the chat box. You can tell me in the chat box too. Awesome. All right, let's see who else we've got working on the board. All right, again, those links are in the chat box. Get those open. All right, let's go ahead. Give me a smiley face if you can hear me, because I want to make sure everyone can hear me since we're not getting a lot of participation right now. Okay, awesome. All right, so I do see smiley faces. So yep, let's go ahead, get some answers on the board since I know you can hear me. Looking good. Got Israel on the board. Thank you. Go ahead, get 2 more answers up there at least, or in the chat box. You can put your answer in the chat box, whatever is easier for you, but let's get our answers up there. I'm going to go ahead and start going over some of them that I see here. I do see Damien is typing though. Awesome. Thank you for participating. Looking good. So up here it says we won the MVLA League for soccer. That's amazing, Efren. Congratulations. You also said that you are ready to graduate. Are you graduating at the end of this quarter then? So not only is it summer break, but it's also graduation. That's so exciting. Where are you located? Do you know which graduation ceremony you're going to be going to? Awesome. I see Amanda on the board, right? So cooking and working out almost every day. That's amazing. So it definitely sounds like some of that habit building and goal making that we've been doing is working for you. Arrow, you said finally able to cut ties with a very toxic friend, right? We've been talking all about positivity as we've been talking about these different intro things that we've been looking at. So yeah, that's awesome. And then Israel, you got A's for all of your classes. Awesome. The one in Tracy, Efren, is that Northern California? Or where's Tracy? I don't remember which one that is. Looking good. Yeah, awesome, Israel. All right, everyone, let's go ahead and get started here. So thank you for your participation here. Oh yeah, so you're in Northern California. Oh, I'm so sorry. I won't be able to make it to that one. I always go to the Southern California ones though. But you can send me a picture of you in your graduation gown, and that would be awesome. Cool. All right. So everyone, please have your link open for the May 14th attendance ticket. Oh, awesome, Andrea. You're graduating as well. That's so exciting. Hi, Ireland. Welcome to class. Again, we have those links in the chat box, passwords there as well. Give me a green check if you're able to open it. I've got 10 green checks so far. Awesome, Andrea. That's so exciting. I love seeing all of you guys graduate. It makes me so happy. All right, let's go ahead, keep on going here. So we only have 22 days left of school. That means 22 days left until some of you graduate, as we've been discussing. So we are halfway through the quarter. We have officially done the midterm exam. Give me a smiley face if you were able to get that finished and submitted yesterday. Those are going to be zeroed out, so make sure that you get those done because it's a really big grade. And definitely watch the recording. Remember, the recording goes over every single question with you to make sure that you are successful on that. Today we're starting unit number 6, so we're going to be talking about mixtures and solutions. We're going to apply that in a lab tomorrow. And then Thursday we will finish up our unit, and Friday we will have a game day to review it. I know last week we missed out on some game days because I wasn't here, so we'll get back in the groove, have some fun on Friday. All right, so mixtures, let's go ahead. This is my family. Yes, this is my husband over here, and then his parents, his mom and dad, and this is my daughter. So yes, we were having some Korean barbecue the other day, and we managed to get a nice picture. All right, so we're talking about Unit 6 mixtures. So today we're going to be learning about how to identify mixtures versus solutions, talk about different types of solutions, and you will be working with solubility in the lab that we're going to be doing tomorrow. So today we should be able to identify the characteristics of mixtures and solutions, explain the difference between homogeneous and heterogeneous mixtures. Smiley faces if you remember these terms vaguely. We actually have already discussed these a little bit when we talked about how to classify matter. Awesome. And then we're going to define some of these words, right? Solution, solute, solvent, colloid, and suspension. So lots of vocab coming your way, and we are going to do awesome at it. So there are many different types of mixtures, so that's what we're going to jump into first. So mixtures, remember, are just when we have different types of matter that are physically combined or blended. So does that mean that any chemical identities are changing? Tell me in the chat box. If we're just physically combining them, are any chemical identities changing? Yes or no? Tell me in the chat box. If it's just physically being blended, like mixing up a bunch of M&Ms together. No, there's no chemical changes, right? If you take some green M&Ms and some red M&Ms and put them together, they're still green and red M&Ms. Their identity hasn't chemically changed, right? You can still eat them. They're still your chocolate M&Ms, right? So mixtures can be physically separated, and remember, physically means that there's no chemical changes that need to happen. Exactly. There's no bonding, right? We don't have to be splitting molecules apart or any of that. It's just physical processes. So for example, if you have sulfur and iron that are mixed together, you can physically separate them, for example, with a magnet. A magnet can physically take out the iron and separate it from the sulfur. Everybody go ahead and give me a thumbs up if this makes sense. This broad definition of mixtures, and then we're going to dive in and make sure we understand the different types of mixtures. Awesome. Thank you, Orlando. Thank you, Shoshana. I got a green check from Damien. Perfect. Thank you, Israel. All right, so there are two types of mixtures, and we've actually taken a look at these already. There are homogeneous mixtures and heterogeneous mixtures. Let's remember back to our prefixes. Homo, does that mean same or different? Tell me in the chat box. This prefix right here, what does this prefix mean? Does it mean same or different? Tell me in the chat box. I see an answer from Arrow. Arrow's typing. Again, still type even if someone else has put the answer because it helps to reinforce your own learning. It doesn't help you if someone else is learning but you're not. They're not the ones earning your grades for you. Yeah, it means same, right? So homogeneous mixtures mean that they look the same throughout, right? So it means that they're blended uniformly. And if you look at the top of a homogeneous mixture versus the bottom versus the sides versus the middle, it all looks exactly the same. We can also call this a solution. All right, so we'll jump into those terms a little bit later, but it's also called a solution, meaning it looks exactly the same throughout, and there's no visible particles. So for example, how many of you have ever mixed salt with water or sugar and water and it disappears and it looks just like water? Smiley faces if you know what I'm talking about. Tell me in the chat box. Smiley faces if you know them and I'm talking about. Or tell me in the chat box. Excellent, right? Okay, so heterogeneous mixtures, on the other hand, what does the prefix hetero mean? Tell me in the chat box, what does hetero mean? Looking good. I see Efren typing, Jacob typing. Yeah, it means that they're different. So a heterogeneous mixture looks different throughout, meaning it's blended non-uniformly. It doesn't look the same throughout. So it looks very different throughout, and usually there are two visible components. So for example, if you mix oil and water, they don't mix uniformly, right? The oil will settle more towards the top, the water will settle more towards the bottom. Same thing with things like rocks or gravel. You mix them together, you can still see the different types of rocks, the different types of gravel, or even things like paint, for example. How many of you have ever opened a really, really old can of paint? Tell me in the chat box, how many of you have ever opened a really old can of paint? And what you'll see is that it actually has layers. So we'll see like a layer of color at the bottom and like a clearer layer at the top. Give me a thumbs up if that makes sense, right? Yeah, it has layers, if you've ever seen that before. Or same thing with like orange juice. Sometimes if you have pulpy orange juice, before you shake it up, you'll see it actually has layers, right? There's like the thicker stuff at the bottom. Yeah, you have to mix it up, exactly. So these are heterogeneous mixtures because, right, you can see their different parts. Okay, so let's go ahead and match these up on the whiteboard. Go ahead, use your whiteboard tools, thin lines, any color but red. Get your answers up there. I'm going to see who's participating. Let's go ahead, get our answers up there. Mixture, heterogeneous, and homogeneous. I see Israel on the board. Go ahead, get your answers up there. I see Amanda and Efren on the board. I'm going to get my... All right, all right. I see Caleb on the board, Tony on the board, Arrow participating. Let's see here. Who else do I have up there? Make sure you're participating, everybody. Want to see lines from Rozzy and Shoshana and TJ and Ethan and Elias, Isaiah. Make sure you're participating. Awesome. I see TJ on the board. Want to see lines from Matt and Michelle, Orlando, Parker. Awesome. Get your answers up there. 5 more seconds, and then I'm going to pause your tools. All right, let's pause those tools. Looking good. All right, let's go ahead, make sure this all makes sense. So, right, just in general, any mixture is going to be when we have different types of matter that are physically combined. Again, physical process, not a chemical process. Heterogeneous mixtures, right, look different throughout, where there's 2 or more visible components, right, hetero meaning different, and homogeneous mixtures are blended uniformly, right, they look the same throughout, hence homo, and that is called a solution as well. All right, give me a smiley face if you feel comfortable with that, if that's making sense. We didn't have any mistakes, but I want to confirm everyone feels good about that. Excellent. Thank you, Israel. Thank you, Orlando. Good, good, good. All right, let's go ahead, keep on moving here. Okay, so now we're going to actually break down heterogeneous mixtures even further. So there are a couple different terms that you need to know. So you need to know suspension and colloid, okay? So a suspension means that we have a mixture of visible particles that appears uniform, but if you let it sit for a while, eventually the particles will settle out. So for example, how many of you have ever looked in the fridge and seen something that says must be shaken well? Tell me in the chat box, how many of you have ever looked in the fridge, looked at something and it said must shake well? Do you guys know what are some things that you need to shake well when you take them out of the refrigerator before using them? Yeah, so juices, right? Tea, exactly. What other things can you think of that it says shake well before using? Shake well before using. Can anybody think of them? We talked earlier about paint as well. Right? There are some examples here, right? Cough syrup. Cough syrup, if you ever look at it, sometimes the particles are suspended, but they'll actually sometimes settle out. Yeah, whipped cream. Yeah, so those smoothies, right? The smoothies kind of need to be shaken well as well. Cool. A great example here is flour with water. Okay, so you can actually see here, I've already mixed in some flour and water together. And what do you guys observe? Tell me in the chat box. What do you guys observe? It's been sitting for like 15 minutes. Tell me, what do you observe after it's been sitting for about 15 minutes? I see Efren typing. I see Jacob typing. I see Caleb typing. Make sure you're participating. Remember, reinforce your own learning, Arrow. Yeah, so we see kind of some flour at the bottom. We see some separation, right? It looks kind of disgusting. So even though I can stir this and make it look uniform for a while, is it going to stay looking uniform forever? Based on what we just talked about, based on what we just observed? No, it's not going to stay uniform forever, right? So even though currently it looks uniform, you can actually see it's already beginning to separate out. It's already beginning to separate. So that's a suspension. So the particles are suspended for a little bit, but eventually they settle out. So the way I think about this is suspension sounds starts with an S, same with settling, right? So suspension is going to eventually settle out. Smiley faces, if that makes sense. No, I am definitely not going to drink that. That would be super gross. Now, a colloid, on the other hand, is a uniform mixture of particles that are permanently suspended. So they're permanently mixed throughout. So how many of you guys have ever seen, for example, on your milk, how many of you have ever seen the word homogenized on your milk? Go ahead, give me a smiley face if you've ever seen that term on your milk cartons, homogenized milk. Okay, so homogenization is really interesting with milk because most of the milk that comes, or the milk that comes directly from a cow means that it's actually going to separate out, right? It'll separate out into cream and it'll separate out into the milk. And it looks really, really funny if you've ever seen real raw, exactly, raw milk, right? Right, Mr. Alch? But homogenized milk is actually goes through a process where it's forced through these different processes that actually break down the particles into even smaller particles so that they can become permanently suspended. That's why you don't actually have to shake your milk. So if you were drinking raw milk, you would have to shake your milk. But the milk you get from the grocery store, you don't actually have to shake it before you drink it because it's already homogenized. Smiley faces if that makes sense. Smiley faces if that makes sense. All right. So this means that milk and things like whipped cream and fog and smoke and mayonnaise, these things don't physically settle, right? If you let your mayonnaise sit out for a while, it's not going to physically settle and separate into layers because that would be really disgusting to look at. Same thing with fog, same thing with smoke. These things don't have particles that physically settle out on their own. Now, a really interesting kind of property of colloids is you can actually see this glowing effect when you shine a light through them. Okay, so for example, all right, let's go ahead and take a look here. So right here, I've got some just plain water and I have a flashlight. Where did my flashlight go? Here's my flashlight. Okay, so I got here we go. So here's my flashlight right here. All right, so what you can see here is that when I shine a light through this, it kind of just goes straight through and you don't really see much of an effect on the water itself. Go ahead, tell me in the chat box, smiley faces if that makes sense. Go ahead, give me a smiley face in the chat box if that makes sense. So yeah, so when I shine a light through it, it doesn't really affect the water very much. On the other hand, when I shine a light through milk, which again is a colloid, a homogeneous, where those particles are homogeneously suspended, you can see that my milk actually begins to glow. Isn't that super cool, guys? Look at that. So you can actually see the milk glowing instead of the light just going straight through. And the reason for this is because, again, these are small suspended particles, and so that light bounces off those particles, and so it creates a really cool glowing effect. You can actually do this at home, right? So you can try water versus milk. It's super neat to look at, and that's exactly why when you're driving in fog and you put the lights on, it really just makes all the fog glow and doesn't really help you see very well. Thumbs up if that makes sense. Okay, so colloids permanently suspended, things like milk, fog, etc. Awesome. All right, so let's go ahead and take a look at this diagram right here. So really, it's kind of difficult to define these perfectly because it has to do with particle size. So really, mixtures, homogeneous, heterogeneous, solutions, colloid suspensions, what it really has to do with particle size. So if you have super, super tiny particles that can actually dissolve and become invisible within the solution, that is called a solution. That's our homogeneous solutions. Smiley faces if that makes sense. So those are the really small ones. Like for example, if I take some salt, hold on one second. Oh, this is not salt actually. This is something else. All right, so here, all right, if we go ahead and we actually dissolve this in, you can see eventually these particles disappear. Okay. And so this right here is going to be a solution because eventually the particles disappear and they aren't going to fall out of solution. Colloids, right? Colloids, on the other hand, have slightly bigger particles that still don't fall out, but they actually allow this glowing effect because they're larger particles. Thumbs up if that makes sense. Thumbs up if that makes sense. So colloids still have all this suspension going on permanently, but they can actually glow because they're larger particles. And then a suspension, right, again, which is a temporarily suspended kind of situation. A suspension is going to have really large particles that can settle out. Okay, so let's go ahead and make sure that makes sense. Grab your whiteboard tools, match these up. Let me know that we understand this. Solution, colloid, and suspension. Get your answers up there. Use your line tools. I have examples for you too, right? So fog, salt water, flour, and water. That should help you out. Go ahead, get to work on that. Go, go, go. All right, I see Efren on the board, Arrow, Israel, and go ahead, get your answers up there. Looks like we have a couple different answers, so keep on working, keep doing your best here. See Caleb on the board, Jacob, Amanda, awesome. Get your answers up there. Going to give you another 10 seconds, then we're going to go over the answers here. All right, let's pause our tools here. Looking good. All right, guys, so solution. Solution, remember, is also called a homogeneous mixture. So these are the really, really small particles that will actually disappear when you dissolve them in the solution, right? So that's things like salt water, sugar water, things like that. Colloids, on the other hand, we talked about, are permanently suspended, and so those ones are actually able to glow, things like fog or milk, because of how light bounces off of them. And a suspension is not permanently suspended. They actually will settle out because their particles are much larger. This is number 1 in your ticket. Give me a green check when you have it saved. You have 30 seconds. Ready, set, go. Perfect. Waiting on a green check from Andrea, Tony, Bradley, Chanel, Damien, Donnie, Edwin, Elias, Ethan, Jade, Misael, Oscar, Parker, Rozzy, and TJ. Green checks for number 1. Moving on now. Here we go. All right, so the last thing that we need to talk about, everyone, is a little bit more about this idea of solutions. Solutions, again, we talked about, are also called homogeneous mixtures, but they can be broken down into 2 parts, a solute and a solvent. Okay, so solution, again, homogeneous, looks the same throughout, uniform, mixture of a solute and a solvent into a single phase. What are the 3 phases? Tell me in the chat box. Think about the phases of water. What are the 3 phases? Tell me in the chat box. You have a hint up here. What are the 3 phases? I see answers from Arrow, from Ethan typing. Yes. Get your answers in there. Yes, we've got solids, liquids, and gases. So if you mix a solute and a solvent together and they go into a single phase, right, it becomes a liquid, or it becomes all a solid, or it becomes all a gas, that is going to be a solution. Smiley faces if that makes sense. Yeah, another word for phase of matter means state of matter, right? We've talked about those already. That was our first unit of the quarter. Okay, so that being said, a lot of times when we think of solutions, right, we think about like your Gatorade, right? Gatorade powdered mixed into water. That's what we think of a solution, where it becomes a liquid. The single phase it becomes is a liquid. However, there are other ones that aren't just liquid, right? So brass is actually a solid solution of copper and zinc together. Smiley faces if that makes sense. So brass is a type of metal that's actually a physical combination of copper and zinc together as a solid, right? Soda pop, right? If you like soda, who likes soda? What's your favorite type of soda? Tell me in the chat box. I really hate Dr. Pepper. I'm a big fan of Sprite though. So soda pop, for example, is sugar, water, and carbon dioxide gas all being put into a single phase, which is a liquid. You like all types, Amanda? Sprite cherry, that's an interesting one. Gross, Dr. Pepper's gross. Now, air, for example, is a solution of different gases, right? The air around you is a solution of nitrogen, oxygen, argon, carbon dioxide, and same thing with clear skies, right? Our atmosphere, our air, again, is made up of solutions of gas, right? So we've got solid solutions, liquid solutions, and gaseous solutions. I have never been to Chili's. No, sorry, Efren. I don't even know where there's a Chili's around us. Do they have those in California? I remember them a lot in the Midwest, but not in California. I've never seen one in LA. All right, so when we talk about solutions, there are 2 parts, okay? They have solutes and solvents. So the solute is the substance that we have the smallest amount of. In other words, it's what's getting dissolved. All right, so if you take a look here, for example, if this person is making a solution of water with a powdered drink, right, the powder is going to be the solute in general because it's what we have less of. It's what's being dissolved. Smiley faces, everyone, if that makes sense. Sprite and blackberry. Oh, that does sound tasty. I am not a big fan of cherry flavor because I'm traumatized from when I was a kid and we had cherry medicine that used to like make me want to vomit. So yeah, I'm not a fond of cherry flavored things like Dr. Pepper, for example. Now, the solvent, on the other hand, is what we have a larger amount of, and this is what's actually doing the dissolving. Okay, the way that I remember this is solute. Is that the smaller or the bigger word? Tell me in the chat box. Solute, is that the smaller or the bigger word? Yeah, exactly. Artificial cherry is gross. I do really like cherries in general, though, like real cherries. Tell me in the chat box. Take a look at the word solute versus the word solvent. Is this the shorter word or the bigger word? Shorter or longer? Shorter word or longer word? Awesome, I got an answer from Ara. I see Caleb typing. I see Amanda typing, Efren typing. Yeah, so this is actually the shorter word. And so this is how you remember it, that this is what we have less of, or what gets dissolved. Smiley faces, everyone, if that makes sense. So the one that's the shorter word, solute, is what's being dissolved. It's what we have less of. The longer word, solvent, is what we have more of, and this is what's doing the dissolving. Doing the dissolving. Okay, so for example, water is considered the universal solvent because water is really good at dissolving most things in our world. It's not great at dissolving everything, right? So it can't dissolve oil, for example, but it's really good at dissolving most other things. That's why, for example, rivers eventually will cut through rock because water will eventually dissolve through rocks. Okay, so again, if we have, for example, all right, we have some water here, and I have some Gatorade powder here. Okay, water, Gatorade powder, which of these is the solute? Remember, solute is the shorter word. Which of these is the solute, the water or the Gatorade powder? Go ahead, tell me in the chat box. Which one is the solute? Again, solute is the shorter word, so think of what we have less of. Shorter word, what we have less of, what's being dissolved. Is that the water or the Gatorade powder? Water, we have less water than Gatorade powder? You just add water to your Gatorade powder container. No, the powder is what we have less of, right? So this is actually the solute. Remember, solute is the shorter word. And so this is what we have less of. Smiley faces, everyone, if that makes sense. So the Gatorade powder is the solute. Now the solvent is going to be our water because solvent is a longer word. And so this is what we have more of. And when we put them together again, what do we get? When you put them together, what do you get? Tell me in the chat box. As I begin to dissolve this in here, tell me what's our final result. What's that called? Again, starts with an S. We've got solute, solvent makes what? Yeah, it makes a solution. Makes a solution also known as a homogeneous mixture. Also known as a homogeneous mixture. Let's taste this. Delicious. All right. Looking good, everyone. Okay, so that being said, some things we need to know about solutions. The concentration of a solution, what this means, the word concentration means that it increases, concentration means that there's an increased amount of solute. So if you have a high concentration, it means there's more solute. If you have a low concentration, that means there's less solute. Smiley faces, everyone, if that makes sense. So you can see it down here. This is a more concentrated solution on the right because it has way more solute. It's much, much darker. Okay, this is like for those of you that like really, really sweet Gatorade and you just keep on adding Gatorade powder to your water until it's way too sweet. On the other hand, diluted or low concentration means there's very little solute. So you can see here, this one is very pale because there's not a lot of solute in it. It is low concentration. Okay, now the interesting thing is, eventually solute will stop dissolving. So for example, how many of you have ever kept on trying to add salt, 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 or sugar, sugar, sugar to a solution, and eventually some of that sugar or salt just stops dissolving? Tell me in the chat box, how many have ever done that? Probably when you were younger, but I've definitely done that when I was a kid. Yeah, just for fun, right? Just to see how much you could do. So eventually it will stop dissolving, and this is what's called a saturated solution. So the point at which the solute will stop dissolving, there's no more room for it, that is a saturated solution. Fully saturated, 100%, so you can't dissolve anymore. So coffee. So you like really, really sweet coffee then, Efren? You're like, how sweet could I possibly make this? All right, so let me go ahead and show you guys a quick demo of this. It's up here, go up on the whiteboard. Thumbs up if you can see my screen here. Yeah, we talk about that in Thursday's lesson, Mr. Alch. But yeah, that's a good thing that we're going to definitely go over. All right, let's go ahead and take a look at this. All right, looking good. All right, so right here, we have a drink mix here. Okay, we could also do something else, right? You could dissolve different chemicals in here. But let's go ahead and put the drink mix in. And you can actually see the concentration here as I add more and more of this drink mix, right? You can see concentration is increasing. Smiley faces if you see that. How as I add more of this, it gets more concentrated, it's getting darker, and you can see the number going up, right? We can see the number going up. Again, smiley faces if you see that. Thank you, Arrow. Looking good. Smileys if you can see that. Thank you, Ethan. Thank you, Orlando. All right, so I'm just going to keep on adding this, and we can still see the concentrations going up. And I'm just going to keep on adding, keep on adding. Let's just add a whole bunch now. And now, what do you actually have noticed? What do you notice is now happening? Take a look at this concentration monitor. What is now happening at this point? Is it still increasing? No worries, Ashton. Glad you were able to make it. Tell me in the chat box, is this number still increasing as I'm adding more and more drink mix? No, it actually stopped. And what do you notice is happening at the bottom of the solution now? Go ahead, tell me in the chat box. What do you notice is happening at the very bottom box? Right? Oh, I'm out of drink mix. That's so sad. Awesome. I see Arrow typing, Caleb typing. Yeah, you can see that there's some of the solute actually just sitting there, right? So it can no longer dissolve. And again, this is what we call saturated. So the concentration can't increase and no more can be dissolved in there. Smiley faces, everyone, if that makes sense. Smiley faces, if that makes sense. Yeah, the rest of the drink mix is just settling there. Awesome. All right, cool, everyone. So all of that is great, right? We've learned all about how to make solutions. Now, the problem is, remember, we talked about the fact that solutions are physical, right? They're physical changes. So if they're physical changes, that means that we should be able to separate out solute and solvent physically from each other, okay? And the main way that we do that, there's actually a couple ways, but one of the main ways we do that is through evaporation, okay? So there are other ways, right? So if the solute is big enough, we can use filtration, which means like a coffee filter, for example, prevents your coffee beans from going into your water, right? But there are other ways that we can do this. And this specifically right here, what we can see here, this process of desalinization, this happens through evaporation. So you can actually evaporate the solvent and that will leave the solute behind. Smiley faces if that makes sense. That's why, for example, if you spill like a sweet drink on the floor and you just leave it for a while, eventually the water all disappears, but it's still sticky, right? How many of you have ever done that? When you've spilled something outside or inside and you never cleaned it up, and then it just gets really sticky over time, right? Because all that sugar has been left there. So even though the water evaporated away, the solute, the sugar is still there. Exactly, Efren. Okay, so a solvent can be evaporated or filtered and leave behind the solute. So for example, this is important because you can actually desalinate water, which means you can get rid of the salt. Okay, saline solution means a salt solution. So desalinization means undoing the saltiness. Okay, so for example, you can actually do this at home. This is a really cool example of if you take two bottles and you tape their openings together, and in one side you've got your dirty water or your salt water, and then you kind of put it on a tilt. Eventually what's going to happen is that heat from the sun is going to evaporate the clean water away into the top bottle, leaving behind the gross water at the bottom. So I actually really recommend, we did this at my old school, do this with the salt water. Don't use dirty water because dirty water Sometimes desalination doesn't work on everything in dirty water, but you can do it with salt water, and this is really cool because you can actually taste the clean water at the top. Yeah, exactly. So the International Space Station, right, they're recycling fluids, which means they're recycling things like urine and then re-drinking that water once it's cleaned through filtration, desalination, and all of those different processes to clean that water, right? So again, once it's separated from that solution, the physical connection between those solutes are restored, and we have that solute back as it originally was. Smiley faces, everyone, if that makes sense. After we just talked about drinking urine. All right, so let me go ahead and show you exactly what this looks like, jumping back into our demo here. So let's take a look here. So for example, if we have a saturated solution, we can get all of that stuff back. Actually, I'm going to actually clear this up and just add a little bit back in here. Okay, so if we have our drink mix here, again, it's all dissolved currently, but what we can actually do is we can eventually evaporate the water, add some heat, and eventually what you're going to see is what is left behind. Tell me in the chat box, what do you see left behind here? I've evaporated the solvent, the water, what's left behind? Only the drink mix, yes? So only our solute, the sugar or the drink mix is left behind. Yeah, distillation, desalination is definitely cheaper than actually having to bring clean water with you. Right? So that's definitely why they want to do that. It's also important to think about because environmentally, if we have a drought or we run out of clean water, we can actually use ocean water, desalinate it, and it becomes drinkable water. Obviously, though, that's not super ideal because that's still more expensive than just already having fresh water, right? So, oh my gosh, Andrea, hope it's okay. All right, everyone, so let's go ahead and match these up on the whiteboard. We've got the word solution, solute, which is the shorter word, solvent, which is the longer word, keep that in mind, and then evaporation. Go ahead and match those up on the whiteboard. Show me what you know. Go, go, go. This will be number 2 in your ticket as well. Get your answers up there. All right, awesome. I see Israel on the board, Arrow on the board, up there. See Efren on the board, Caleb on the board. Amanda and TJ participating. Awesome. Up there. Thank you. Thank you. Keep working. I see Jacob on the board. Give you another 5 seconds. Brianna's on the board. 3, 2, Oscar's on the board. 1 and 0. Let me pause your tools really quick, shrink these down, and let's see what we got. All right, looking good. So solution, yes, we said this is a uniform mixture of 2 substances into a single phase, right? So we talked about solid solutions like brass, liquid solutions like salt water, and gaseous solutions like our atmosphere. The solute is the shorter word. It's what gets dissolved like salt. Solvent, the longer word, is what does the dissolving, what we have more of like water. And evaporation is a method to physically separate the solvent from the solute. Excellent job. This is number 2 in your ticket. You have 45 seconds to get this done. Green checks when you have it saved. Go, go, go. Gets dissolved is what we have less of. What does the dissolving is what we have more of. Awesome. Need a few more green checks. Waiting on Ashton and Bradley, Damien, Chanel. Let me know if you're having any issues in the chat box. Waiting on Dusty, and thank you, Dusty. Donnie, Edwin, Elias, Jacob, Josiah, Jess, Caleb, Matt, Oscar, Blossom, Suji, TJ, Yoleze. Green checks for number 2. We're going to move on in about 10 seconds. Chanel, if you need to, take a picture and then give me a green check, or you can tell me what's going on in the chat box. All right, here we go. Let's keep on moving here. Chanel, if you need help, let me know after class, okay? All right, everyone. So we talked about mixtures versus solutions, homogeneous versus heterogeneous mixtures, and then all about solutions, solutes, solvents, as well as colloids and suspensions. Excellent job. All right, we're going to go ahead and send you really quickly your 6A quiz. Remember, the quiz questions are related to what you see on your attendance ticket. So your attendance ticket does have all of the information you need to get 100% on your quiz. Do them side by side and then submit them at the same time. Smiley faces, everyone, if that makes sense. Again, Mr. Alch will be getting you those links in just a moment. Awesome. I see a smiley from Orlando. Amanda, thank you. Efren, if you have a question, let me know in the chat box. Thank you, Andrea. There we go. There's those links. All right, so make sure to open up your quiz, do it right away using your attendance ticket so that you can get 100% on both. Awesome. Here you go, everyone. This is your last word. Have a great day, and I will see you tomorrow for your lab. Bye.